this is the paper session number 4. We have 5 very interesting presentations. My name is Ruben Alonso from Natural Solution. We will start with INPERSO, with 2 presentations from INPERSO from the Universitat Politécnica de Valencia. Professor Luis Alapont will present the INPERSO project. Then Juan Gabriel Secondo Maglia will present the 3D printing system for facade restoration. And then we go to the Centro Tecnológico de la Construcción de la Región de Murcia. I think that Carlos will present, but Miriam is also here in case there is any question. So it's about the SNAC project and the advancing sustainable and energy efficient buildings through circular material innovation at optimal cost. So it's a little bit too long. Yeah. Then Julia de Aloisio from Certimac will present the circular building passport to support sustainable and positive energy homes, which is part of the LEGOFIT project. And then the session will be closed with Constantina Dia Andreoli from Mirtec, also INPERSO project, presenting mapping sustainability construction materials supply chains. And at the end, I will close the session. The presentation will be more or less 10 minutes, 12 minutes. We will do the questions after the presentation. If you have any question, anybody wants to ask something, please do it after the presentation. So we start with the presentation. We control the time and thank you to give you in the 10-12 minutes. Okay.
Thank you, Ruben. Thank you for your understanding of our needs and for make so easy everything to us. And I'm sorry for the inconvenience for the organization. Okay, presentation. Well, thank you for doing this presentation. I'm going to present the general aspects of INPERSO, industrialized and personalized sustainable societies. Well, I think everybody knows this challenge, this big challenge to the construction sector. I think we have told it this morning in the first section. 40% of final energy consumption and 36 of greenhouse gas emissions. We are guilty for these numbers, and well, we have to focus on renovating existing structures to mitigate this problem. However, the renovation rates have stagnated. What is the proposal of INPERSO? INPERSO proposes innovative solutions, flexible to adapt to the specific characteristics and needs of each building and user, and industrialized and digitalized processes to improve the retrofit works, reducing the time and disturbance and increasing comfort and energy savings for everyone. Well, let's have a look, a quick look on the project in a nutshell. INPERSO tries to look into the problem from a threefold perspective: products, processes, and a human-centric approach. This means that we try to be holistic and cover the whole life cycle. That's because the project will feature 3 distinct phases: the decision and design phase, the first phase, pre-retrofit, that includes collecting all the data and the information, identifying system requirements, specifications, and developing low-carbon renovation models. Okay, we were talking about the second phase, during retrofit phase. We are going to install advanced renovation components and technologies. Well, we will see something more about it later. The third phase is the validation phase, validation and demonstration phase, the post-retrofit phase. Using wireless sensor network, the project will provide holistic energy management using AI and machine learning, allowing to users to optimize energy usage. Well, this is our consortium. It's a large consortium. We are 22 partners coming from 9 countries. Many people from Spain, but also from Greece. We are 8 RTOs, also 8 SMEs, many SMEs, and 3 large enterprises, and also 3 NPOs that are in charge of this of our 3 pilots. Well, let me. Okay. Now we move to the objectives of the project. We have 6 integrated results to achieve in INPERSO that are aligned with the project's objectives. The first is deliver integrated digital platform. The second one is to generate new carbon renovation models. Sorry. The third one is try to improve the using of advanced manufacturing technologies. And specifically, we are going to deploy on-site 3D facade printing that Juan is going to explain in the next presentation. We try to also address personalized energy and comfort requirements of users. And finally, we want to deliver a complete system test in the 3 pilots that we are developing. And we are going to do this using advanced technologies. Starting with the RE Suite platform, and that is an AI and AR-based solution. The platform has been already developed in the project. We are in the 3rd year of the project, and it's been tested in the 3 demo cases in different scenarios. All the information and data are available through a user-friendly interface, and we are including the Sky tool that can recognize objects from a points cloud and integrate it into a BIM model. It is also connected to the Rialto application, which uses artificial intelligence technology to audit and report on construction management work. And R2M is developing a big part of this. Moving to the low carbon renovation models, INPERSO aims to address the fragmented construction value chain. Low carbon renovation models developed are prioritizing user satisfaction and sustainability, working together with all the stakeholders. We have developed also a dynamic map that has been integrated to the RE Suite platform, which will help all participants to make better decisions. The energy and comfort optimization interface is the last one of the digital tools. We have, well, it consists of a multi-stage energy consultant system that is connected to this interface. Using a low-cost wireless sensor, wireless network sensor to evaluate air quality, energy demand, and comfort conditions. And finally, the retrofit kit, the physical part of our project. It aims to reduce construction and demolition waste, enhance productivity, upskill the workforce, improve workplace conditions, and reduce embodied CO2 of buildings. This is the retrofit kit. We can start with the smart wall. It's a prefabricated all-in-one wall panel. It's a multi-layer system that can even include autonomous air conditioning devices and other types of products as PV panels and so on. The second is the energy pod. It's an intelligent plug-and-play HVAC system that uses PCM material, and it incorporates also energy storage and PV inverter. The third one is this type of building integration photovoltaic panels to be installed in roofs and balconies with a special interest in heritage buildings. Next, we have solar window. The solar window includes a PV Venetian blind shading device inside an insulating window between two glasses. And well, this kit is composed by some of our innovative products that INPERSO is going to integrate in the pilots in order to achieve TRL 8. Of course, we have the 3D printer system, but I'm not going to talk to you about it because the next presentation it will do. Okay, let's move to the pilots, to our 3 pilots. We are going to explain briefly these technologies that have been implemented in the demo cases. One is located in Spain, the second in the Netherlands, and the third in Greece. The first is a social housing rental building whose main facade and volume are protected and with market on its ground floor. Well, Calle Estrella is located in the historic center of the city, and you can see in the pictures the 2 facades that has the building, one facing to the city and the other to the courtyard. And well, we have had multiple difficulties to develop this project, but finally we are developing the project. Of course, we are monitoring 10 of the 16 apartments, and we are doing interventions in 7 of it. The first one is installing 6 new balconies with 5 PV panels, groups of PV panels that are going to be installed in the back facade that is not protected, and will receive this facade a commercial ethics. You can see the final design on the bottom right side of the screen. We are going to install we are going to install in 4 apartments this type of solar windows that are designed specifically for the protected facade, the main facade. We are also installing 4 units of the smart wall on the indoor side of the facade. And finally, 4 units of the energy pod will be fitted in 4 apartments. Moving to the next pilot, the Trinity Complex, it's in Bell. There are 3 high heritage protected buildings, the church that was not allowed to intervene, and 2 ancient monasteries, one called Emmaus and the other Bronhorst, that have been converted into temporary residences for low resource people. Due to this high level of protection, the intervention has been finally restricted only to Bronhorst Monastery, which has been monitored since the beginning of the project. Well, despite of the small scale of the intervention, a big impact is expected due to the big issues that always appear on this type of heritage building. Well, the work is small, but the results are huge. Only 1 room is going to be intervened, installing a solar window and a smart wall unit. But also we are going to install on the area 1 energy pod on the attic to supply 2 of the rooms. And finally, we are going to do the most interesting intervention for me, the most interesting restoration work that it consists in replacing part of the damaged chapel roof with photovoltaic tiles. with the same shape and the same finish as the originals. Well, this is the third pilot. It's located in Baribola, Poliameni, near Athens. I don't know if I have said correctly. It has yet completed already completed its renovation, and unlike the previous two, we are starting it in the coming months. And it consists of the energy renovation of a social residential building that is built in the 1960s, now dedicated to people at risk of exclusion. In this case, in order to compare INPERSO technologies with traditional solutions, a commercial ethics has been applied to some parts of the facade. On the right side, you can see in two levels, in blue, and on the left side, you can see in the side facade and the main facade, the southeast facade. At the same time, the smart wall solution was installed in the first level of the south facade, as you can see in pink, employing 27 units, 4 of them with ventilation system integrated. INPERSO panels from Metso were also installed at the pergola, as you can see in green, and the roof. Conventional panels, not integrated panels. And finally, this is the last, sorry, Ruben, for the extension. We present the expected impacts that are already being evaluated. You can see both time and cost savings and quality improvements regarding the full life cycle, the construction phase, and the operational phase. And thank you for your attention. That's all.
If anybody has a question while I put the next presentation, feel free to ask.
Yes.
You
now, because we are going to
yeah. No, I have a. I mean, do you have anybody have a question about the project? If not, I ask. Okay. I mean, I saw that you had a few sessions with the stakeholders.
Yes.
How different were between different countries? I mean, you did, I suppose, one in Spain, one in Netherlands, one in Greece.
Yeah. Well, I'm not directly participating on the sessions, but I know something about it, of course. I think in Greece it was very, very difficult because tenants or residents are people at risk of exclusion, and they are not very interested in this type of renovation and so on. And they are changing, I don't know, every period. I think that here the most important is the managers of the building, the contact with the managers of the building. They are willing to participate and to do this type of renovation. That was good with them, but with many restrictions about the residents. In Spain, it has been difficult, but I think it has worked better because the tenants, because they are tenants and they are not owners, it's managed by a public company, AUMSA, and they are in contact with the tenants every time and trying to engage them, and well, with the help of our partner that is represented by Raul. He's from Tau, and they are doing a very, very good job with people. And well, I think that's because in Valencia we have been able to intervene with many in many apartments and with the engagement of the people. And in Belp, well, it's more or less the same with the residents as in Greece, but it's more difficult because the managers of the building have been changed and they are not very involved in the project. That's because the size of the scope of the place.
Okay, thank you.
Thank you.
Luis.
Thank you, Robert.
Let's go with the last presentation of today. Open it. So, you have it. So, Constantina Di Andreoli from Mirtec.
Thank you
Please.
very much. Good afternoon to all of you. My name is Diandrouli. I'm coming from Greece, from MIRTEC, Materials Industrial Research and Technology Center. And we'll go back to INPERSO project. The first two presentations showed you the technologies we developed in this project. And now I will present you our approach in mapping sustainability in construction material supply chains. To remember a little bit the technologies that we're working for INPERSO, we are talking about 5 technologies: smart wall, a wall panel, energy pole, building integration photovoltaic system, solar windows, and facade 3D printer. So the objective in our part of this work was to map the supply chain for all these 5 technologies, assess the qualitative sustainability, performance, and provide insights in order to improve the circularity of all these technologies, because these technologies are targeting a TRL 8. That means that they are very close to market and all these issues need to be dealt. And in order to proceed with this, first of all, we need to understand the construction value chain and then develop a methodology in order to identify the points that we can that can be improved. Here you can see the construction value chain. We start with the raw materials, continue the manufacturing of the basic products. Then we have the construction site, all these works. Of course, the concept design, engineering, and at the end of the construction project, of the building project, we have the phase of the operations and maintenance until the end of life and the need for demolishing or for innovation of the building. And in all these stages, we have a large number of waste, a large number of raw materials. The construction value chain is very complex with all these very high numbers that speak for themselves. So, in our approach to establish a sustainable supply chain, we are trying to make a qualitative analysis for the environmental point of view. And we need then to see all the landscape, the EU policy, the regulatory landscape, in order to be ready and make some actions for entering the market for the technologies we are targeting. Then we start with the collection of the data of the supply chain and proceed with the environmental sustainability assessment and validation. Starting with the very first one, the policy and the regulatory landscape, which is relevant to the sustainability and supply chains. And here we can start with with the directives, which are have to do with the reporting, let's say, directives. The first one was in force until the last year. And we have the new Corporate Sustainability Reporting Directive, which is in force from this year. Large companies are under this scope, and in this directive, we have also the information of the entire value chain. So, the entire value chain of the construction and building materials are under the scope. We have also the Corporate Sustainability Due Diligence. This is mandatory from, it's published in July of last year, for all member states until July 2026, it will be also a directive. So all the member states will have these also mandatory actions. It refers to thousands of large companies. However, SMEs are also indirectly impacted from this directive because they are becoming partners or suppliers of the large companies. So all these are affected by this new directive. And for the Corporate Social Responsibility Directive, we have also the requirement for all scopes, scope 1, 2, 3 emissions. That means, again, the supply chain is needed for all these calculations. And for scope 3, it is written that when there is a high scope 3 emissions percentage, then the companies need to take immediate actions. We can see that in the construction sector, the companies that are there, the scope 3 is 90%. So, for these kind of companies, it is very important to take these actions. Identify major emission hotspots through the screening of the key suppliers, implement efficient logistics, and implement circular economy principles. So, we have also the last new regulations. The new European Construction Products Regulation, published this year, it will become applicable from next year, and for first time it includes the in Annex 1 the sustainable use of natural resources as the basic requirement for harmonized technical specifications. And the last one, the revised EPPDs, well, as we saw from the previous presentations, it will be also, let's say, related with the global warming potential, and for all new buildings, it will be mandatory from 2030. So we are talking for a boom of EU regulations, directives that need to be, let's say, taking care of the companies. And if technology provider need, let's say, to take some actions in order to enter the market, need to know all these directives and be ready to enter the market. So, in our approach, we started with collecting data for a linear, let's say, supply chain. We start with the raw materials, with suppliers of the subcomponents for INPERSO technologies. Then we have the assembly of all these components, the installation, the end-of-life treatment, and the landfill. This is the linear, but we want to have it circular. So in circular, let's say, supply chain, we can see that we have also the reuse, the recycling towards a zero landfill. That means we need to take actions in order to have the minimum construction and demolition waste also in this map. So, in our, let's say, activity in collecting all this data, mainly the primary data, we face difficulties because only the first level suppliers, it was possible to give some input in our research. Even in this case, there were, let's say, non-uniform collected data. So again, there were some difficulties. And in order to go back to the value chain, we need to take also secondary data and need to make a literature review for all the components from which we didn't have some information. In order then to, let's say, to focus on the sustainability evaluation, we decided to redirect our analysis toward evaluations of sustainability in the reverse supply chain. And we, for all these 5 technologies of INPERSO project, we did the assessment based on 6 evaluation criteria. We collected for all these the locality of the first level suppliers, the degree of geographical concentration within the supply chain, the alignment with the design for disassembly principles, the resilience of the supply chain with regard to critical and strategic raw materials, the efficiency of reuse and the recycling processes, but also the existence of efficient collection networks. The output of our work was the development of a geographic information system visualization tool that we show in the next slide. An Excel tool with all the information that we collected for all these technologies from primary data collection, the materials flows and key materials required by each technology, and the sustainability, the circularity sustainability performance, and also try to give insight to each technology provider for these 5 technologies in order to improve their performance. Here you can see the visual representation of material flows for all these 5 technologies using this GIS tool. When we started the collection of data, this was the case. After the technology providers understanding that there is a need even to change the supplier or even to change and redesign their products in order to include more sustainable materials, we end up with a more centralized, let's say, map of the material flow. These arrows have to do with the flow from first-level suppliers to INPERSO technology developers, and from technology developers to the demo sites where these technologies and these assemblies were installed. So we can see that we managed to have in Europe all the technologies and all the materials in INPERSO project. The other issue, the other aspect that was very important is to understand that we need to minimize the construction and demolition waste. But in this case, we had a big problem. We needed a baseline, and it was very difficult to find the methodology for a baseline. We decided that EPDs is one, let's say, solution, one way to compare some trusted data with our case, and we started looking for EPDs. Again, we had difficulties, as you know. In the published EPDs, first of all, there are only a few EPDs. But for the published EPDs, you can see that most of the publications refer to the very first stages of the life cycle, and only a few for the end of life stage. So when we managed to find some published relevant EPDs, again there were some difficulties because you have a new technology. It is an innovative technology. Then you need to make again some assumptions in order to be in a position to make some comparisons. And here we selected the case of smart wall from INPERSO technology in order to calculate the construction and demolition waste reduction, and have some quantitative also result. We select this prefabricated facade because it supports a wide selection of materials. It can have several different sizes. This system allows a very easy redesign, so it was easy for us to redesign and change materials in order to see the effect on the construction and demolition waste reduction. And for the comparison and the baseline, we used a published EPD with a conventional ethics. The findings from this case was, of course, the integration of design for disassembly methodologies into the design phase was very, very important. Replacing the chemical fasteners with mechanical ones allow the selective demolition and drastically reduces the construction and demolition waste. Also, related to materials, with careful material selection, again, we had an improvement. For example, using inorganic coatings on cement boards, it was able to avoid landfilling of after the end of life. So, selecting the appropriate inorganic coating for this material, we could have a reduction of construction and demolition waste close to 98.5%. Also, using lightweight cladding, again with mechanical fixation, it was let's say, ready to give construction and demolition waste reduction up to 60%. So, concluding, we can say that the life cycle supply chain holds a significant potential to drive sustainability in construction. For example, by early adoption of design for disassembly principles, by careful material selection, and of course, implementing efficient logistics and screening all the key suppliers, it is possible the technology developers to enter the market with reduced and improved environmental performance of their products. That's all from me. Thank you.
Any question?
Is there another presentation?
No, it's the last one, and we close. We close on time. We have time for one question. You don't have.
Yes,
you have. Please.
Very, very interesting. Thank you. And I'm also reflecting on what we do. And it's true that, well, maybe Julia didn't mention because it maybe not necessary, but when we looked for EPDs, we also decided quite early on that we will only, for the building level, at least use phases A1 to A3 of EPDs because we couldn't find the other phases.
Yes.
Very
rare.
So that, that's another challenge that we never mentioned. But do you have a French partner on the project or on your project?
No.
Because as far as we know, so we looked at EPDs from different countries. The French regulation is the most strict one. And very recently, they're like, no, you have to include everything and all the assumptions fully transparent. So actually, there's a lot of pressure from the French government to give you the most accurate EPDs. But no, the other countries, not really. Maybe they will be pushed further on to give you, so that you can have more transparency and carefully select the logistics supply chain, which is very, very important. It makes, I think, a big difference. And for the baseline, you said you had trouble finding a baseline. Yes, it's because it's an innovative technology.
It is an innovative technology.
Yeah,
always you need to take some assumptions, but
yes,
you need to have also some traced data.
Yes, so I think the best you can do is to take generic EPDs for the materials that you use, if they are available, like generic concrete, and you need to justify that you have alternative materials, and if you put them, so.
Yes, you're right.
But they're very interesting, and I'll look into.
It's a challenging
task.
So,
yes.
Perhaps very quickly, you had 3 presentations today. So we saw specific materials. I mean, we saw the whole, say, overview of the project. What's the next step? Because there could be specific applications, but then there is this. What you showed now is much bigger. So, if you very briefly can say, let's say, what's the next ambition?
Even
what is most familiar?
Coordinator, I can let's say show you an overview. All these 5 technologies can be, let's say, enter the market by themselves, or can be integrated as a retrofit kit. So at this moment, the project is, let's say, examining the way that will enter the market or the business model, because some of these are collaborated, let's say, results. So we are, this is the last year of the project. So at this moment, the technology providers and the other partners are trying to find the business model in order to go to the next steps. Most of the technologies are in high TRL, except the printing one, which will reach TRL 7. But all the others are, let's say, ready to do the next step.
And in terms of patenting, is there already?
I don't know.
I can't really answer you. I don't know, because as they have different approach to the market, I don't know if they have been doing this kind of patenting analysis assessment prior to try to do that. So I don't really know. It's up to the technology providers. Okay.
Okay, thank you. I think that we can close the session. I want to thanks José Luis, Juan Gabriel, Carlos, Julia, and Dia for the presentations. Also all the projects like INPERSO, SNUG, and LegoFit, and all of you for coming. And see you next year, probably in Luxembourg for Sustainable Places 2026. Thank you.